What's up, guys? B-Man homework.
That's Mr. Davis.
Hey, this is Zach. What's up, 8th graders?
So that was just a quick hello from Zach and Mr. Davis. What we're going to be doing today, you see, is we're turning the following fractions into decimals. We're reviewing some skills we did last year. So I'm going to zoom in here on the 1/5, and the first thing I want to do is I want to take 1/5, and I want to, and I want to turn that into a decimal. So I can take fractions and turn them into decimals by dividing. My fraction bar right here means to divide, so I'm going to do that. This is 1 divided by 5, so I'll write that as top goes in, bottom goes out. This is 1 divided by 5. Now I need to ask myself, how many times does 5 go into 1? Well, that goes in 0 times because 5 can't go into 1. I know that I want my answer to be a decimal, so I'm going to add a decimal point here and put a 0. I know that I can do that because it doesn't change the value at all, right? $1 is the same thing as $1.00. Those are the same thing. If we have a decimal point, we can add as many zeros as we'd like afterwards, and that doesn't change the value. So if I have my decimal point here, I need to bring it straight up. It also goes here. 5 goes into 10 2 times, and 2 times 5 is 10. 10 minus 10 gives me that perfect remainder of 0. I always make it a smiley face because we're usually pretty happy about that. So 1/5 is the same as the decimal 2/10 or 0.2. Awesome, we've got that done. Let's go to our next one is 5/8, and I want to turn 5/8 into a decimal. Same thing I'm going to do is division because my fraction bar means to divide. I can divide 5 divided by 8, so I go top goes in, bottom goes out. Now I'm going to do 5 divided by 8. First thing I want to ask, how many times does 8 go into 5? Well, 8 doesn't go into 5, so that's 0 times. I want to express my answer as a decimal, so I can put my decimal right after my 5 and add a 0, because that does not change the value. If I have my decimal here, I want to bring it straight up. I'll also put my decimal up top. 8 goes into 50. That happens 6 times. 6 times 8 gives me 48. And now I can subtract. I can borrow if I need to. 10 minus 8 is 2. 4 minus 4 is 0. So 50 minus 48 is 2. Now, a common mistake that a lot of people make is what they tried to do is they tried to take this 2 right here, and they try to move it all the way up here and say that this is 0.62. That is a silly mistake. That is a 6th grade mistake. We're not going to make that mistake. I need to continue to add zeros and bring them down if I have a remainder. So I will add another 0 because that doesn't change the value, right? 5 is the same thing as 5.00. I've added my other 0. I bring it down. 8 goes into 20. That happens 2 times. 2 times 8 is 16. I can subtract. 20 minus 16 gives me 4. Now I still have this remainder of 4. I don't want to make that really goofy mistake and take that 4 and try to bring it up. That does not work, right? I can't take this 4 and try to bring it up here. Instead, I need to add a 0 and bring it down. I need to continue to do this until my numbers start to repeat or until I get a remainder of 0. What's going to happen that's awesome this time is we're going to get that remainder of 0. 8 goes into 40. That happens 5 times. 5 times 8 is 40. Write that down here. 5 times 8 is 40. 40 minus 40 gives me that wonderful remainder that I love, which is 0, and it makes me happy. So I can then take a look at my final answer. 5/8 as a decimal becomes 625 thousandths, or 0.625. 2 more quick examples. So those ones ended up being perfect. You'll see in the first one we had, right here we had this remainder of 0, which made us very happy. And the one that we just did, we also had a remainder of 0, which also made us very happy. What's going to happen in the next one is we're going to have ones that aren't quite as perfect. So let's go over to this one, 1/3. I want to figure out what 1/3 is as a decimal. So I can do division, top goes in, bottom goes out. 3 goes into 1. Well, 3 goes into 1 0 times. It doesn't fit. I'm going to add a decimal and a 0. I'll bring my decimal point up. Now I can look. 3 goes into 10. Well, that happens 3 times. And 3 times 3 is 9. 10 minus 9 gives me 1. I still have a remainder of 1. Again, I don't want to make that really silly mistake. I can't take this 1 and try to move it up here. That would be a foolish mistake that a 6th or 7th grader would make. So I still have a remainder. I need to add another 0 and bring it down. Well, this is starting to look really familiar. 3 goes into 10 3 times. We already saw that once. 3 times 3 is 9. You can start to notice that the same pattern is going to be happening over and over again. We're never going to get that perfect remainder of 0 that we want. Instead, we're going to continue to get 3's the whole time. So once I start to see a number repeat, I can stop. And I can express that this is going to be 0.3333. 3's are going to go on forever. So this bar that I drew right up here, above it, that bar tells me that my decimal is repeating. I can stop once I start to see a pattern or a decimal repeat. Let's take a look at our last one. We have the fraction 7 over 33. Let's make this fraction into a decimal. I can do that by dividing. Top goes in, bottom goes out. I have 7 divided by 33. How many times does 33 go into 7? Well, 33 is bigger than 7, so it goes in 0 times. I will add my decimal point and a 0. Once I have my decimal point here, I'm going to bring it straight up. It also goes right here. 33 goes into 70. Well, I'm going to think of 33. 33 is about 30, just to help me estimate. So how many times does 30 go into 70? That happens 2 times. So 33 goes into 70 probably 2 times. Let's see, 33 times 2, that's 66. Now I can subtract. 7 minus 66 gives me an answer of 4. I have a remainder. I can't bring it up. I need to add another 0 and bring it down. How many times does 33 go into 40? Well, 33 fits into 40 1 time. And 1 times 33 is 33. I will subtract 40 minus 33. It gives me 7. I still have a remainder, so I need to add another 0 and bring it down. Now, what you may start to notice, I'm just scooting this over so it's easier to see. What you may start to notice is we've already done how many times does 33 go into 70, but let's try it again. I know that 33 goes into 70. That happens 2 times. 2 times 33 is 66. Oh, we've seen this before. 70 minus 66 gives me 4. If I add another 0 and bring it down, I'm just going to get into the same pattern that I have been in before. 33 goes into 40 1 time. You'll start to notice that I have 2, 1, 2, 1. This is going to continue to repeat. All fractions at some point start to repeat, and this one's repeating at 21. So this I can write as the fraction 0.21 with a bar over it. That 21, 21, 21 is going to repeat forever. Awesome. You have the rest of your packet to do. Those are those 4 examples that we did. I'll zoom in and leave it on this screen if you need to look at it. But you have the rest of the packet front and back side. Good luck.